All right, so good little warm up here. Let's start with a good, nice, long division problem from I almost said from yesterday, Monday. See what you remember. See what you have. So, x plus 2 goes on the outside. X cubed minus x squared plus 4x minus 10 goes on the inside. X squared would be what makes the same, the first the same. So then that's x cubed plus 2x squared. Change both signs. That gives me negative 3x squared. Drop. Then this would be negative 3x. Change gives me, oops, wrong color. That would be positive 10. Change gives me negative 30. So my final answer would be x squared minus 3x plus 10 plus negative 30 over x plus 2. Agree? Yes or no? Yeah. Okay. All good. All right. Long division is good for what it is, but there's something else out there. Oh yeah, it's coming.
Can I brush?
And miss this guy?
Yeah.
You guys really love that old school.
Hold on. Oh yeah. Oh yeah.
Is this?
Oh yeah, it's this guy.
Polynomials. But if you had fancy red, yeah, like
Ketchup.
right. I'm talking about maybe mobile, synthetic mobile, no, synthetic division. Yes. Here's our topic. Right. What do we need to do? We need to be divided by special linear factors in order to use synthetic division. So let's talk about how we're going to get into this game. All right. Special linear factors. Yeah. Something like these guys. Okay, this is not a special linear factor. Why? Because my leading coefficient of my variable is not 1. What makes a special linear factor? A special linear factor has coefficient 1 and degree 1. An example of a special linear factor is x minus 2. Okay, this is x minus c. Okay, what goes outside of our box? The opposite of c, or whatever's going to make our denominator 0. I'm ready for an example. Okay, yes. Am I divided by a special linear factor? Yeah. So then, okay, zeros go outside of the box. What makes that denominator 0? Minus 1. Zeros go on the outside. Coefficients go on the inside. Coefficients are numbers in front of the variables. Here we go. I'm going to put a 1. I'm going to put a 3, and I'm going to put a 2. Oh, this is actually long division without the actual coefficient, and we need our special linear factors. So then what do I first do? Drop the guitar, drop the guitar. Minus 1 times 1 gives me a minus 1. Very nice. 3 minus 1 is 2. Okay. Minus 1 times 2 is a minus 2. Oh, and our remainder is 0. What does this mean? This means that x minus 1 is a factor of x squared plus 3x plus 2. You're going to be using something called the factor theorem to determine that. Yes. But that's neither here nor there. Where is it? Yes. We're taking 1 degree out of the numerator. It was a degree 2. So now I'm going to write my answer as 1 degree less than 2, which is 1. X plus 2 is going to be the quotient of those two polynomials. And then what? And a flower. Now look here. Okay. Yes. Am I dividing by a special linear factor? Yes. So what goes on the outside? Zeros go on the outside. What's 0? Anything that makes that polynomial 0. What's going to make this polynomial 0? 1. Okay. And a different color. Yeah. 1 is on the outside. What goes on the inside? My coefficients. Yes. A 1 goes in there. A 2 goes in there. A minus 3 goes in there. And a 12 goes in there. Okay. So then I drop the guitar, you know, yeah, whatever. That was my song with one of my ex-girlfriends. Yeah, and yeah, I went away, and I'm not gonna finish that story. Anyway, she dropped me like it was hot. Oh, messed up, right? She was a horrible person. No, she wasn't. Yes, here's the 1. This one says that one, put it there. That's the 1. 2 and 1 is 3. Tee. This one says that one, put it there. That's 3. Tee. Adam. None. Yes, this one says that one, put it there. 0. Oh, Adam, you got 12. Oh no! What does this mean? Let's go through. Rewrite our quotient. Yes, I had to be 3. This is gonna take it down a notch. I wish you would take it down a notch. Hey, whoa. So instead of degree 3, it's now gonna be degree 2. So then this is gonna be x squared plus 3x plus no constants, but I do have a remainder. And how do I write that? I write a remainder over divisor x minus 1. Fun. And then what? And flower. And when I said I was away, I wasn't talking about like to the yeah, no, I had to go do somewhere else. Here we go. What makes this denominator 0? 2. Yes. So I put a 2 on the outside, and then I put the coefficients on the inside. I put a 1, then I put a 0. Why? Because I need a placeholder for my x to the 3rd term. Yes. So 0x to the 3rd plus 0x squared minus 1x plus 2. Okay. Oh, I need placeholders on the outside, zeros, and then on the first one, trouble is hard. There's a 1. 1 times 2 is 2. Very nice, Adam. 2. 2 times 2 is 4. Sure, Adam. 4. 2 times 4 is 8. Great, Adam. That's a 7. 2 times 7 is 14. Adam. That's a 16. Okay, that's my remainder. I'm divided by a linear factor. I need to take it down a notch. This is x to the 3rd plus 2x squared plus 4x plus 7 plus remainder 16 over divisor x minus 2. Look at that one. Oh, yes. Yeah, I do think it's a hammer. Because it's hammer time? No. Because we nailed it.
Alright, so now let's do the same problem that we did for the warm-up, except now we're going to do it synthetic divisional way. Okay? Now, synthetic division is great, but as the guy said, It only works if we have a special linear factor. And that means that we have a 1 in front of as our lead coefficient, and it's a linear factor. So it can only work if it's x plus c. Okay? If it's 3x plus 4, that doesn't work. We can't use synthetic division for that. We got to go long division. Okay? That's why we didn't start with long division, because synthetic division doesn't work in every case. Long division will work in all of those cases. Okay? So he said zeros go on the outside. Okay? So zeros are what makes this 0. So what makes that equal to 0? -2. So -2 is going to go on the outside. Now, how you draw the synthetic division like work area, that's fine. He draws his like this. Okay? I draw mine usually like this. Okay? Doesn't really matter. Okay? Inside then go coefficients. So you start with the biggest exponented term, and then you got to have a coefficient all the way down. So 1, -1 for x squared, +4 for x, and -10 for the constant. Okay? Then drop it like it's hot. So the first one just comes straight down. Gives me a 1. Then I multiply green times red. That gives me -2. Then I add those two together. For the longest time, I thought he was talking to himself, and his name was Adam. His name actually is Adam. Okay? But he was saying add them for these two. Okay? Longest for years, I thought he was like talking like he's going Adam, Adam, Adam. And I'm like, no, he's going to add them. So that's -3. Now I multiply purple and red. That gives me +6. Add those two together. That gives me 10. Multiply orange and red. That gives me -20. Add those together, and that gives me -30. Because we started with a degree of 3, we took it down 1 degree. Then our answer is going to be x squared minus 3x plus 10 plus -30 over x plus 2, which should be the same as what we got when we long divided it. Okay? But again, synthetic division only works if we have those special linear factors. Okay? So, here's our function. I'll give you a second to write the function down. Half of x is equal to x cubed minus 6x squared plus 5x plus 12. Once again, that was half of x equals x cubed minus 6x squared plus 5x plus 12. If we plug 4 into that function, the result is 0. Prove it for me. Plug 4 into that function and see if you get that the value of the function is in fact 0. Four cubed, what's that? 64? 6 times 16. 96? 20 plus 12 is 32. 32 plus 64 is 96. 96 minus 96 is 0. Okay? Okay? So what that means, since f of 4 is equal to 0, that means that x equals 4 is a root, a 0, a solution of the function, and that x minus 4 is a factor. Okay? So if we find a number that we can plug into the function, we get out 0, okay? That means that that number is a root, a solution, a 0, an answer, if you will, to the function. But it also means that this is a factor. Okay? So how you go about doing that is you basically say to yourself, well, x equals 4 produces f of x equaling 0. Okay, so that's what we just proved. We would work one step back above that, and we would subtract 4. So that gives us our factor. Zeros are all the way done. So you get answers, zeros, roots, all that fun stuff. Okay. One step before that is the factor line. Back when we were solving by factoring, what was that, last week? We were solving by factoring. Okay. And remember how I said you set your factors equal to 0? Okay. That was the factor line. Okay. So then, because we know that, and this is a special linear factor, we can use synthetic division to find the other factors. Now, I think, or do I put the bus stops? Oh, I put the bus stops there. Okay. All right. So, x minus 4. So we're going to say, what was it again? X cubed minus 6x.
Plus 5x plus 12.
Plus 5x plus 6. Whoa, 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 whoa. Minus 6x squared. Then what did we say? Plus 5x. And then what was left? Plus 12. And we want to divide that by x minus 4. Okay. Well, we can synthetically divide that out, right? Okay. So, what's my 0? 4 was my 0. Set it up the way that he had it set up. My coefficients are 1, negative 6, positive 5, and positive 12. Drop it like it's hot. Multiply. Add. Multiply. Add. Multiply. Add. And it should get 0 right there, because we already plugged it in and we said it was 0, right? So we should get 0. So what this is saying is, that the result here, or let me even go back a step. We started with x cubed minus 6x squared plus 5x plus 12. That's a bad 12. That's where we started. Okay. And being the same 2. What's going on? Why is it catching over there on this side? There we go. That's a better 2. Okay. Then we're saying that x minus 4 is a factor, which also leaves me with the other factor of x squared minus 2x minus 3. Is x squared minus 2x minus 3 factorable? What's factor? Negative 3 and plus 1? Yep. So this would factor then to be that. Then we could say, now that we have all those factors, right? If we went back up here and we said, oh, let's make this be equal to 0, now we could say that x equals 4, x equals 3, and x equals negative 1 are our answers. Okay? We can do all of that stuff now. And so we call those the 3 bus stops. Okay? You gotta know when you get on the bus where you've got to get off. Okay? The first stop is you are just simply being asked to divide them. Okay? I'll put that in this purpley purple-ish purpleness. That was this step right there. That is just the straight up dividing, and you get this as your answer. With me? That's stop number 1, where it's just a divide problem. Okay? Bus stop number 2 says you need to factor your polynomial completely. That, oh, let's go with 3, is this step right there. Bus stop number 3 then says, find all the zeros, the solutions, the roots, the answers. That one's relatively easy because that one you just, we'll go with pink for this one. That one, you just set all of your factors equal to 0. That stayed in there. Okay, good. Set all your factors equal to 0 and get it. Okay? Now, the nice part is in the directions for each problem, it should tell you what bus stop you're going to. Okay? If it is just a straight up divide problem, like we saw on Monday, like we saw earlier here, right here, that's a straight up divide problem. Okay? That is bus stop number 1. Okay? You will see the words factor completely if it is bus stop number 2. Okay? And you will see the word solve usually for bus stop number 3. Okay? So you're looking for the division symbol or a fraction or the word divide for bus stop number 1. You are literally looking for the word factor for bus stop number 2, and you are looking for either find or solve. put it into work. Given the polynomial f of x and a factor of f of x, it says factor f of x completely. Which bus stop are we at? Bus stop number 2, right? Because we're at the factor bus stop. If you go to bus stop number 3, you are wrong. And I will mark it wrong. Okay? If you only go to bus stop number 1, wrong. Okay? We can jump on the bus out in front of school here, actually. Yeah, we can jump on the bus back open in front of school. And I want to get downtown. But if I get off at John Muir, am I downtown? No. Okay? I'm not. So I got to get off on my right bus stop. Okay? So we know that this is a factor. Because it said so right there. If that's a factor, what is my 0? Positive 3. Okay. Can I use synthetic division on this one? Yeah, because it's a special linear factor. So let's use synthetic division. It's faster. Coefficients are 2, negative 11, 3, and 36. You'll see why here in a minute. Okay. Drop it like it's hot. Gives me 2. 2 times 3 is 6. Negative 11 plus 6 is negative 5. 3 times negative 5 is negative 15. Negative 15 plus 3 is negative 12. Negative 12 times 3 is negative 36. Those add together to be 0. So this polynomial right here factors to be x minus 3, because that was told that that was a factor, times 2x squared minus 5x minus 12. Who is interrupting me by calling? Here, actually, we're going to answer this one. All right, so now we're here. We're factored, yes. Okay, but are we factored completely? Now we've got to look at this, because that's a quadratic now. So now we can see if we can butt cheek it. The 2 sets of parentheses to make sure that that one can be factored. What am I going to put in my first 2 spots? 2x and x. Love it. Okay. Now for 12, my choices are 1 and 12, 2 and 6, 3 and 4. Anybody got any feelings? 4 and 3? You want to go 4 first or 3 first? 3 first? If that's the case, then this gets me 3x. This gets me 8x. Together, those have to be negative 5x. So which one's going to be positive?
The 3.
The 3. If that's positive, then this is positive. This would be negative, that would be negative, and I get my negative 5x. Right? Okay? So the complete factorization here would be x minus 3, 2x plus 3, and x minus 4. That would be the complete factorization.
You put it equals 0. Like, can you say?
Like, so, and then keep solving it?
No.
Okay. because we are just asking to factor it, technically what we should do here is we should go f of x equals. Yeah. Because putting it equal to 0 would be going to bus stop number 3. Okay? Ooh, I like it. What bus stop are we going to?
1, 3.
Which one? Give me both. What is it asking us to find?
You have a 0.
0. So is that bus stop number 1?
3.
1 is just divide them out, right? Okay. 2 is factor completely. 3 is 0. So this is bus stop number 3. Find me, how many zeros do we need total? We need 3 total zeros because we've got a degree of 3, right? So I gave you 1. How many do you have to find? 2. Find them for me. Go. So if 9 is my 0, what is my factor? If 9 is a 0, what's my factor? 6. You got it. X minus 9. Yep. Okay. So if 9 is a 0, x minus 9 is my factor. So we know that 9 is a 0, so that's going to go, we're going to synthetically divide that line. So then we've got 2, negative 10 for the x squared, negative 71 for the x's, negative 9 for that one. Drop, multiply, add, multiply, add, multiply, add. The reason I write it like that is because now this becomes f of x equals my x minus 9 from my original 1 times 2x squared plus 8x plus 1. 2x squared plus 8x plus 1. Can it be factored? No. We gotta find those zeros though. So what do we have to do? Quadratic formula on that one. So on this one, it would be x minus 9 equals 0, but that already gives me that 0 that was already given. Okay, so that one's there. So then 2x squared plus 8x plus 1 equals 0. So x is going to be negative 8 plus minus square root of 8 squared minus 4 times a times c all over 2 times a. 8 squared is 64. 2 times 4 is 8. 64 minus 8 is 56. Can 56 be simplified as a radical? Four goes in there how many times? 14 times. So that would be 2 square roots of 14. Looking at my 3 outside numbers, negative 8, 2, and 4. Can any of those be, or is there a common factor that goes into all 3 of those? 2 goes in there. So the 3 zeros that we found are 9 and -4 plus
Or
the
minus.
square root of 14 over 2 and -4 minus the square root of 14 all over 2. So we do have the 3 answers that we needed. One of them was given to us. We had to find the other 2. Okay? We'll pick up more of this next week. We'll have more problems along the lines of what we just did today. And then we'll also have problems next week of, here's a function. Go find me all the zeros. Factor it completely, all that fun stuff. Okay? Where we don't give you that stuff.